Okay, welcome to the first page of notes, everybody. So we're going to go over solving just a little bit, but more importantly, before we begin to solve equations, there's some new words that you need to become familiar with that I'm going to be using throughout the year. But first, let's go back and see if we can remember what does it mean to solve an equation. So let's focus on this first. And a lot of people will say, well, get x by itself, or do the opposite and things like that. But what it really boils down to is that if you're going to solve an equation, you are going to find the value that makes the equation true. So that's your job. When you solve an equation, you are trying to find the value for that variable that will make the equation true. Now, we will get into solving, and actually, you've been solving equations since 7th grade, but this unit actually is more when you solve an equation and you do your steps, you are explaining why you can do the things you do. Why can you add a number to both sides? Why can you divide both sides by a number? But that will all come later. For now, what we're going to do is we're going to look at this equation over here. And just as a reminder, the difference between an equation and an expression is that an equation has that equal sign right there. Just so you remember. So we've got this equation, and there are 3 new words that you need to know that have to do with this equation and other expressions. But the first one is coefficient. Okay, so a coefficient is a number, and I'm just going to use a symbol because I'm too lazy to write number, is a number in front of a variable, or I should say a group of variables. Okay, so if I were to go and highlight all the coefficients in this equation, 3 would be one of them, -7 would be another one, and even though there's a y in there and an x, we care about the one in front, so -7 is that coefficient. Then 4 would be a coefficient, and we're looking at that x on the very end. Now some people think, oh, there's no coefficient there, but there actually is. There's a 1 right there, and so actually -1 is another coefficient in that instance. Now the next word that I'm going to talk about is constant. Okay, now the definition of a constant is a number with no variable. Sorry, my writing's kind of nasty. It's just because I'm writing on my iPad. It's tricky. So, a number with no variable. So if I go through and I try to find the numbers with no variables, +2 is one of them, and -1 is the other one. So those are the only 2 constants in this equation. So you need to remember also to take the sign with it. Okay, that positive goes with the 2, and that negative goes with the 1. So make sure you include those when you're talking about your constants and your coefficients. So the last thing that I want to talk about is what a term is. So a term is, I guess you could say, a piece of an equation or an expression. So if I was going to tell you what a term was, the way that I could define it the best is that terms are separated by a plus or a minus or an equal sign. So I'm just going to go and put a box around every term in this equation. So if you look, there's a negative right there, and since it goes with the 7, this is my first term. And then there's the plus with the 2, so this is where my next term is. And here's my next one. The sign always goes with it. 4xy is another term. Here's another term. And there's another term. So there's actually 6 terms in this equation. And that'll depend. I mean, it just depends on how many, how big or small your equation is. So, knowing what you know now about those things, what a coefficient is, a constant is, and a term, let's go over to these examples right here and identify all those things. So the number of terms, and the coefficients, and the constants. So, first of all, let's do this. So let's write down terms, okay, and we're going to list how many terms there are, and I'm going to draw around them again. So the first one is right here. So negative 4x is a term, positive 7 is a term, and negative 5 is a term. So the answer to that is 3. There's 3 terms in this equation. The next one we'll do is coefficients, and I'm just going to write coefficients. And this time I don't want you to tell me how many there are, I want you to tell me what they are. So if I go through the coefficients, are negative 4, and that's actually the only one. So I'm just going to put negative 4 for that one. Oops. Negative 4. And then the last one are my constants. Okay, so I'm going to go through. My constants are positive 7 and negative 5. Okay, so we're going to write those down. So we've got 7 and negative 5. So that's the first one for you. So let's do the second one. So 6 equals negative 8 plus w over 7. So let's start with writing what our coefficients are. So actually, let's go back and let's do terms first. My bad. Okay, so here we go. Terms. Okay, so if we were to put a box around them, here's one, because they're always separated by a plus, a minus, or an equal sign. And then here's the next term. I take the sign with it. And here's my next term. So there's 3 terms in that equation, again. Now, if we were going to talk about the coefficients, the numbers in front of the variable, then that would mean, interesting. Now, there is a 7 there, but it's underneath the w. Now, if it really was, and so, well, people would want to put 7 as the coefficient. The thing is, if 7 was the coefficient, it would look like this. It would actually look like 7w. But what's weird about this 7 is that it's underneath. So let me explain something. And I'm kind of going to go off for a little bit, and I'm going to come away from this for a second. So let's say you have a number. I'm totally making this up. If I take a number and divide it by 3, I'll get 2. Now, that's if I divide by 3. Is there something that I can multiply 6 by and still get 2? I know if I divide by 3, I'll get 2. But what can I times by and still get 2? Well, the answer is a fraction. So, dividing by a number or multiplying by its fraction do the same thing. So think about that as I'm over here with that w over 7. Another way that I can write that is 1/7 w. Those mean the same thing. So dividing by 7 is the same as timesing by 1/7. So really, the coefficient is 1/7. Now, to go to that last one, let's do our constants. So, sorry about that. Our constants, in this case, we've got a negative 8 and a positive 6. Those are the numbers without the variable. So we will write negative 8 and positive 6. So that's what we get for the next one. Now, let's go to the third one. This one's kind of a funky one. So we'll write down, so let's write down the terms. I'm going to write down all these at once. The coefficients and the constants. So if you look at the terms, a lot of people think, well, terms are in between the pluses and the minuses, and there aren't any pluses or minuses. So there's no terms. The thing is, there's still something sitting there. And so if there were no terms, there would literally be nothing there. But that is a term right there. So there is one term in that thing. Now, coefficients. Remember what I said, how normally we don't see it, but there is a coefficient in front of that x, and it's a 1. So the coefficient is a 1. Now, the constant. The constant is the number without the variable. But there are no numbers that don't have a variable with them. So in this case, what we'd write for that is 0. So that's just kind of an overview of what coefficients are, numbers in front of variables, constants are numbers without variables, and the terms are separated between pluses and minuses and equal signs. They're the pieces of the equation. Now, to go on to this, let's go into solving just a little bit. Now, I want to tell you something, and something that I want to remind you of all the time, but when you solve, you can do whatever you want to both sides. Like literally, you can do whatever you want to both sides of an equation. You could multiply both sides by 50. You could times both sides by pi. You could divide both sides by 8.3. You can do whatever you want to both sides of an equation. But you need to just know how to do it correctly. So what I'm going to do is split this box into 2, and we're going to talk about 4 main things that you're going to do to both sides of an equation this year in math. So 2 of the things that you're going to do to both sides are adding and subtracting. The other 2 things you're going to do are dividing and multiplying. So let's talk about adding and subtracting for a second. If I had an equation like 3x plus 4 equals 10, you look at that and you ask yourself, well, I mean, if you solved it, and I'm sure you could because this is grade 7 stuff, but x would have to be a 2. And it's true, if you put a 2 in there per x, you'd get 3 times 2, which is 6, plus 4 is 10. Now, I am not here to solve this. That's not my point. The point of this little section is to show that you can do whatever you want to both sides of an equation, but you have to do it right. So let's say that I wanted to add 3 to both sides. So here we go. Actually, I'm going to use a different color here. So I'm going to add 3 right here and add 3 right there. And my result is, let's see, 3x plus 7 equals 13. Now, that's a whole new equation. I did what I wanted to both sides just for fun. And if you put a 2, we said that x was 2. If you put a 2 in that equation, 3 times 2 is 6, plus 7 is 13. It still works. So it just goes to show you can do whatever you want to both sides and it'll still work. Now, I have seen people do this to both sides of an equation. So I'm just going to erase this for a second. Now, I have seen people do this. They add a 3 to everything, to every term in that equation. But if you think about it, there's 2 things that are wrong with that. Number 1, you can't add 3 to 3x. Those aren't like terms. One has an x and one doesn't. And if you think about it, look on the left-hand side of the equation. How much did you really add over there? You actually added 6. You added 3 right here and 3 right here. You added 6 to that side, and then you only added 3 to that side. So you can't do that. You have to be super careful when you're adding things to both sides. You only do it once to both sides, and that'll take care of it. Now, just for fun, I'm going to subtract something on both sides. I'm going to minus 5 on both sides. And make sure you're copying this down in your notes with me. So what is the result? So we get 3x plus 2 equals 8. So let's look at it. Put in 2 for x. If I put a 2 in there, 3 times 2 is 6, plus 2 is 8. It checks out. So when you're adding or subtracting on both sides, you just have to remember you only need to do it once, and that'll take care of it. Now, on the other hand, multiplying and dividing is a little bit of a different story. So I'm going to put in 4x plus 1 equals 9. Okay? So, if we look at this, let's see. Oh, if you solve that, you will find that x is 2. And it's true, if you put a 2 in there, 4 times 2 is 8, plus 1 is 9. Now, if I'm going to multiply on both sides, let's start off by doing it. I've seen in the past people do this. Multiply, I'm going to multiply by 4, so I'll do it there. I'm putting a dot, and there. I'm multiplying both sides by 4. And the result that I get is 4x plus 4 equals 36. Well, let's check. Is the answer still 2? So if you put a 2 in there for x, you get, let's see, 8 plus 4 is 12. So that did not work at all. So when you multiply something by 4, or by any number, you can't just do it once on both sides like adding or subtracting. Okay? So when you do it, let's try this now. I'm going to also multiply this by 4. So all 3 of those terms got multiplied by a 4. Now let's put the result. So 4 times 4, so that would make 16x plus 1 times 4 is 4, 9 times 4 is 36. So let's look at it now. So if I put a 2 in for x, let's see, 16 times 2 is 32, plus 4 is 36. It totally works. So when you multiply an equation by something, you have to do it to every single term if you want to keep the answer the same. Okay, so if you want to keep the solution as 2, you have to multiply everything. So now, just to show you something, I'm going to erase this right here. Let's divide both sides by a number. So I'm going to divide both sides by 2. Now, remember, dividing goes the same way. If you're going to divide both sides of an equation, you have to do it to everything. And there's a couple of ways you can do that. You could go like this, and you can divide literally each term by 2. So you can show me like that. Or another way that you can do it is to just divide that whole side by 2 and that whole side by 2. Whichever way you want to show me is fine. But the result, so 16 divided by 2 is 8x. Positive 4 divided by 2 is positive 2. 36 divided by 2 is 18. Now, we did say that x was 2, so let's put a 2 in there. 8 times 2 is 16, plus 2 is 18. It totally works. So, when you ever multiply or divide, you have to do it to everything. So write that at the bottom. Okay, that's really important. If you're ever going to multiply or divide, you have to do it to everything. Now, just to kind of go back up here for a second, so you know how when we multiplied everything by 4, we just literally showed that? There's another way that you can show that too. If you wanted to multiply everything by 4, you could also use parentheses and show me that way, that you're multiplying everything by 4. I don't care how you show me, as long as you show me that you're doing it to everything. So, let's do some examples on the back. We've got 2 examples. The first one is negative 8 minus x, all over 5 equals negative 9. So if you notice, that 5, everything is getting divided by that 5 on that side. So, hold on just a second. Sorry about that, I had to sneeze. So, if you notice, everything over there is getting divided by a 5, just like I showed you on the other page. Now, we really are going to solve this. We are trying to find the number that we can plug in for x that will make that equation true. That is your goal. And so, yes, you will have to get that x by itself. And so now you have to start thinking, what do I need to do to both sides that's going to help me? Because you can do whatever you want to both sides, but You want to do things to both sides that are going to help you get that x by itself. Now remember, there's actually a 1 in front of this x right here, so I'm going to put a 1 right there. Now, first of all, we need to get rid of that 5, and we need to get rid of that negative 8 eventually, and actually that negative 1 that's sitting in front of the x. We have to get rid of all 3 of those things. So, just as a tip, you cannot get rid of that negative 8 or that negative 1 right now. Because right now, both of those are being divided by a 5. So the first thing we've got to do is figure out what we can do to both sides that's going to get rid of that 5. So you have to think to yourself, well, what's happening with the 5 right now? What is the 5 doing? Well, everything is being divided by the 5. So if you want to undo that, you're going to have to multiply by 5. So that's what we're going to do. We're going to multiply everything by 5 on that side, and we're going to multiply everything by 5 on that side. Now, when we do that, these 5s undo each other, because one's being multiplied, one's being divided. And that was the whole point. I wanted to get rid of it anyway. So we're left with negative 8 minus 1x equals, and we'll multiply that, and we get negative 45. So, if you notice, our equation's getting smaller, which is great. That's what we want to happen. Now, we can get rid of the negative 8, we can get rid of the negative 1. So, look at what's happening with that negative 8. It's just sitting by itself. It's a negative 8. And so you think, well, what could I put on both sides that would get rid of a negative 8? Well, a positive 8. So I'll put a positive 8 on that side and a positive 8 on that side. So our result, the 8's are gone, they undo each other, which was the whole point, and we're left with negative 1x equals, let's see, negative 45 plus 8 is negative 37. Okay, here we go. Now, the only thing that we have left to get rid of is that negative 1, so we have to think, well, what can I do to both sides that would get rid of that negative 1, that would undo it? So look at what's happening. What's happening between that x and that negative 1? Well, when you see a number and a variable sitting together like that, it means they're being multiplied. So if it's being multiplied by a negative 1, then I'm going to do something to both sides that will get rid of it. So I'm going to divide by negative 1 on both sides. So negative 1 divided by negative 1, those undo each other, and the only thing you're left with is x. And then over here, negative 37 divided by negative 1 is just a plain old 37. So, there's your answer for that one. Now, the next one, we are going to still solve for x. We're trying to find that value for x that will make the equation true. Now, I'm going to do something that you're not used to seeing. But, let's say I wanted to get rid of that 9. You're going to have to get rid of that 9 and that negative 8 either way. But I want to get rid of the 9 first. So you look and say, well, what's happening with the 9? Well, it looks like the x is being divided by that 9. So if I want to undo that, I'm going to have to multiply by 9. But remember, if you multiply 9 to one thing, you've got to do it to every single term in that equation. So the result, well, here the 9's undo each other, because that was the whole point. We wanted to undo those 9's. Oh, whoops. There we go. Sorry, my bad. So you're trying to undo those 9's. So those 9's undo each other. Oh, mercy. There we go. Alright. So you want to undo those 9's. So those 9's cross out and you're left with x. Now, negative 8 times 9 is negative 72. And then 11 times 9 is 99. So, there we go. We're getting very close. The x is almost by itself. The only thing we have to do now is get rid of that negative 72. So, here we go. Now, since it's a negative 72, there's nothing else around it. It's just a negative 72. Well, if I want to undo a negative 72, I'm going to put a positive 72 on both sides. And let's see our result. Now remember what I said about adding and subtracting. We just got to do it once to both sides and it takes care of it. So those undo each other. That was the whole point. And then 99 plus 72 is 171. So, there's our answer for that one. So just keep in mind when you're solving these equations, because that's what we'll be doing this whole unit, is as you're solving equations, think about what you need to do to both sides to undo those numbers that are around the variable. What can I do to get rid of it? What will be an advantage to me? Anyway, well, until the next video, see ya!